So I'm Myrna.
I'm Martha.
And I'm Jada.
Today we will be talking on Chapter 7, Experimental, Quasi-Experimental, and Ex Post Facto Design. So the first thing we will be speaking on is the overview of an experimental design, practically. So pretty much, in a descriptive designs described in the preceding chapter, we make no systematic attempt to determine the underlying causes of the phenomenon being studied, but sometimes we do want to know what leads to the next thing, which is to identify the cause and effect relationship. A researcher can most convincingly identify cause and effect relationship by using an experimental design. In such a design, the researcher considers many possible factors that might cause or influence particular conditions or phenomena. The researcher then attempts to control for all influential factors except those whose possible effects focused on the investigation. So pretty much, an experimental design will start by having two groups, maybe more, depending on your exact design you're going through. And then the members in each group will have very similar characteristics. And then we'll have a pretest to measure a particular characteristic in which we're interested in, to see the before and then the after. Then we will expose only one of those groups to treatment or intervention of some sort. Afterwards, we'll give both groups a post-test to measure that characteristic. If the characteristic changes for the group that received the intervention but does not change for the other group, we can reasonably conclude that the treatment or intervention brought the change we observed. And then lastly is we have systematically manipulated the situation using an experimental design if our results change in the post-test. Following will be, so this is pretty much review independent versus dependent variable. An independent variable is one that the researcher studies as having a possible effect on one or more other variables. In many of the designs described in this following chapter, you will see down the road, the researcher directly manipulates and controls at least one independent variable, in contrast to the dependent variable, which is a variable that is potentially influenced by an independent variable, that its value depends on some degree on the value of the independent variable. So then next will be the internal validity of a research. So a particular concern any experimental study is its internal validity, the extent to which its design and data yields and allows the researcher to draw legitimate conclusions about cause and effect and other relationships. In an experimental design, internal validity is essential. Without it, a researcher cannot draw firm conclusions about cause and effect. And that is, after all, the whole point of conducting an experimental design. Continuing on is the co-founding variable. Whenever we have two or more groups that are or might be different in ways, in addition to particular treatment or intervention, we are studying the co-founding variables in the study. The presence of variables make it extremely difficult to draw conclusions about cause and effect because we can't pin down exactly what it is that causes any pattern in the data observed after the intervention. In other words, co-founding variables threaten a study's internal validity. So strategies used to control confounding variables. So the first one is you will keep some things constant. When a factor is the same for everyone, it cannot possibly account for any differences observed. Oftentimes, researchers ensure that different treatments are imposed in the same or very similar environments. They may seek also for research participants who share certain characteristics such as age, gender, grade level, and just their overall, if they share any characteristics. Then next will be to include a control group. In chapter 4, we described a study in which an industrial psychologist begins playing classical music as employees in a typing pool go about their daily task of typing documents. At the end of the month, psychologists find that the typist productivity is about 30% higher than it was in the preceding month. The increase in productivity may or may not be due to the classical music. There are too many possible confounding variables. Personal changes, nature of the documents being typed, number of people that are sick or on vacation during the 2-month period. Even just the knowledge that an experiment is being conducted may also account for the typing pool's increased productivity. To better control for such extraneous variables, researchers frequently include a control group, a group that receives either no intervention or a neutral intervention that should have little or no effect on the dependent variable. The researchers then compare the performance of this group to an experimental group, also known as a treatment group that participates in an intervention. So then next we will need to randomly assign people to groups. We spoke about the value of selecting people at random to participate in a descriptive research. Such random selection enhances the probability that any results obtained for sample also apply to the population from which the sample has been drawn. In an experimental studies, researchers use random selection for a different purpose, to assign participants within their sample to various groups. And then fifth is to expose participants to all experimental treatments. Still, another strategy for controlling for individual differences is to use participants as their own controls. To have every participant in the study undergo all experimental and control treatments, and then assess the effects of each treatment independently. Any independent variable that is systematically varied for every participant is known as a within subjects variable. And an approach that includes a within subject variable is a within subject design. And then lastly is to statistically control the confounding variables. Sometimes researchers can control for the unknown confounding variables, at least in part, through statistical techniques. And then moving on will be to the first design, which is the pre-experimental design. Experimental designs are helpful only for forming tentative hypotheses that should be followed up with more controlled studies. So the first design will be the one-shot case study. The one-shot case study is probably the most primitive type of experiment that must conceivably be termed researched, only as research. An experimental treatment, TX, is introduced and then measured OBS, a post-test of some sort, is administered to determine the effects of the treatment. The design has low internal validity because it's impossible to determine whether participants' performance on the post-test is the results of the experimental treatment. Many other variables have influenced participants' performance, such as psychological or experiences else in the participant's general environment. It is very simple to carry out this study, and its results for all intents are, in the end, are meaningless. They have researchers could use the following design, which is the next design we will be talking about, better, which is one group pre-test, post-test design. It's better than the first one. In a one group pre-test, post-test design, a single group undergoes a pre-experimental observation or evaluation. Then B is administered the experimental treatment. And finally, C is observed or evaluated again after the treatment. This design is presented through this graph right here, which is group 1, then OBS, TX, and OBS. And then the next design is the static group comparison involves both an experimental group and a control group. Its design is it will expose an experimental group to a particular experimental treatment. The group is the control group, while the control group is not. After the treatment, both groups are observed and their performance are compared. In this design, however, no attempt is made to obtain equivalent groups or even to examine the groups to determine whether they were similar before the treatment. We have no way of knowing if the treatment actually causes an observed difference between the groups. So moving on, we'll be talking about the true experimental designs, which are, they offer a greater degree of control and a result of greater internal validity. The first 3 or 4 designs we discussed shared one thing in common. People or other units of the study are randomly assigned to groups. So the fourth design is the pre-test, post-test control design. In a pre-test, post-test control design group, people or other units of study are randomly assigned to either an experimental group or a control group. The experimental group is observed, subjected to the experimental treatment, and observed again. The control group is isolated from any influences of the experimental treatment. It is simply observed both at the beginning and at the end of the treatment. Moving on is to the fifth, this one has one potential problem it's named the Solomon 4 group design. It has one potential problem in the preceding design, is that the process of observing or assessing people before administrating the experimental treatment may influence how people respond to the treatment. For instance, perhaps the pre-test increases people's motivation. It makes them want to benefit from the treatment received. Such an effect is another instant of the reactivity effort described in Chapter 4. So this one will have 2 additional groups who are not pre-tested and provide a particular advantage, which is going to be groups 3 and 4 shown over here. If the researcher finds that the final observation groups 3 and 4 differ in much the same way that groups 1 and 2 do, then the researcher can more easily generalize his or her findings of this to the situations in which no pretest has been given. In other words, the Solomon 4 group designs and enhances the external validity of a study. Moving on to the post-test only control. This one offers a solution. It is a lot more simple. you can't pre-test the forces over here, and there's only 2 groups and each group will be randomly designed to its group. And the next one is, these are all still about the true experimental designs that really work, which is design 7, within subjects design. We spoke about earlier the nature of within subjects, also known as a repetitive measure design, in which all participants receive all treatments in a research study. And then this design, all participants will receive the treatment. Various treatments are administered very closely together, one behind the other, very stimulously. So everyone's getting the same exact thing. You can't tell the difference. So no one is getting different treatment. The effects must be fairly localized and unlikely to spread beyond the specifically targeted behaviors.
So quasi-experimental designs, these are used when randomness is either impossible or impractical. Some example designs of this include Design 8, non-randomized control group, pre-test, post-test design. This one involves 2 groups that aren't random, but incorporate the pre-treatment observations of design number 4. Design 9, simple time series design. This one consists of making a series of observations, introducing an intervention or other new dynamic into the system, and then making additional observations. The sequence of observations made prior to the treatment is typically referred to as baseline data. Design 10, control time series design. In this one, 2 groups are observed over a period of time, but one group, the control group, doesn't receive the experimental treatment. Design 11, reversal time series design. This one uses a within subject approach as a way of minimizing, though not entirely eliminating, the probability that outside effects might bring about any changes observed. Design 12, alternating treatments design. This one just means including 2 or more different forms of experimental treatment in the design. And then design 13, multiple baseline design. This design requires at least 2 groups. Prior to the treatment, baseline data is collected for all the groups, and then the treatment itself is introduced at different times for each group. Ex post facto designs. In these, researchers identify events that have already occurred or conditions that are already present and then collect data to investigate a possible relationship between these factors and subsequent characteristics or behavior. An example of this, I believe it was Wynne, who was researching the recent lack of trust from the government on scientists and their recommendations. In this case, the lack of trust would be the current conditions, and her data could show a relationship between other factors that caused this distrust. Like correlational research, it involves looking at existing circumstances, but like experimental research, it has clearly identifiable independent and dependent variables, but neither is being manipulated. An example for this design would be simple ex post facto design, in which 2 groups, an experienced group and a normal typical group, and then you compare and contrast the characteristics of these 2. Factorial designs, when a researcher examines the effects of 2 or more independent variables in a single study, this approach is known as a factorial design. Some examples of these would be the 2-factor experimental design, which involves 2 independent variables, and you examine its effects by comparing it to different groups. Design 16, combined experimental and ex post facto design. In this one, you divide sample into 2 groups based on the participant's previous experience or pre-existing conditions. Then the researcher randomly assigns members of each group to one of the 2 treatments. And meta-analysis. So a cause and effect relationship exists between an independent variable and a dependent variable only if we have directly manipulated the independent variable and have controlled for confounding variables. Even when taking precaution, the possibility that our alleged cause doesn't really produce the effect we think it does, so we conduct replications. A meta-analysis is an analysis of all the analysis. So researchers combine the results of many experimental and/or ex post facto studies to determine whether they lead to a consistent conclusion, and this relates to everyone's project because data must be replicated multiple times in order to concretely prove a correlation. But given our limited time, it is unlikely that anyone will be able to pull off doing multiple experiments. Therefore, our meta-analysis will most likely be combining results of our own experiments to the pre-existing data we gather from our research.
Conducting experiments on the internet. Researchers can now conduct research studies on the internet, such as descriptive studies and experimental studies. Internet-based experimental studies don't necessarily have to be one-shot affairs. In some instances, an internet-based research study might be quite suitable for your research question. However, keep in mind that ethical practices ensuring protection from harm, they are informed consent and have the right to privacy are as important in online experimental research as they are in any face-to-face studies. Testing your hypotheses and beyond. Experimental and ex post facto studies typically begin with specific research hypotheses, such as subsequent statistical analyses should be conducted to test these hypotheses, and analyses often take the form of a t-test, analysis of variance, or analysis of covariance. Acknowledging the probable presence of bias in experimental research. Other biasing factors such as group selection procedures, statistical regression, and differing attrition rates can adversely affect the internal validity. Internal validity is the extent to which the observed results represent the truth in the population we are studying and, thus, are not due to methodological errors. Acknowledging the probable presence of bias in experimental research. Other biasing factors can negatively impact the external validity of an experimental study. The external validity is the extent to which you can generalize your finding to different groups of people, situations, and measures. This connects to my research topic about renewable energy in the United States. Some challenges may include the absence of data, especially in relation to energy consumption, as well as accurate, nonpartisan data concerning energy production in the United States. Further challenges could include limits in energy storage and transmission technologies currently in place in our country. Practical application. Furthermore, a researcher's expectations and hypotheses are likely to bias a study from the get-go. Try as we might, we human beings cannot completely have objective and unbiased in our well-intended efforts to make better sense of our physical, social, and psychological worlds. Thank you.